Yeah, welcome to Easy Mathematics and a new video. Today I want to talk about the JEE exam. I don't know if I pronounced it correct. JEE Advanced. And first of all, I want to give some general hints before we look into two examples in detail. Okay, I want to talk about not only how to solve it, I want to talk how you can spot the right way. There are a couple of tricks you can do, and we will talk about that. Okay. So first of all, how to solve these crazy questions. It sounds stupid when I say read the whole task carefully. What do I mean by that? We will see that in detail. Yeah. And then the second step is you should think about the given conditions carefully. What do you know about that stuff? What might help? And if you look at the answers, some of the answers, they tell you how to choose the right solving strategy. Okay, you will see what I mean by that. And 4, solve the question. Most of the JEE Advanced questions, they look horrible in the first step, but if you think carefully, they are more or less straightforward. Okay, how to prepare? You should know, of course, about standard techniques like geometric series, telescoping series, system of equations, important trigonometric identities, basic matrix properties, Riemann integrals. The Riemann summation is often a good choice. Yeah, but the big question is how to choose the right way. Yeah, and one general hint is do not work stupid, think smart. This sounds also very easy. You will see what I mean by that. Yeah, if you take a look at the structure of the question, the structure and also the answers, they give you many hints. And if you know enough about certain stuff, then the problem is straightforward and very easy. Okay, and I want to show you two examples from 2019 I solved. It's from 2019, sheet 2, question 3. There are 6 matrices, P1 to P6, and a matrix X, and this is defined by the summation of the product pk times a matrix M times pk transposed, where pk to the power t denotes the transpose of the matrix pk. Okay, then which of the following options are correct? X is symmetric if x times vector 111 equals alpha times vector 111, then alpha is 30. Third question, the sum of diagonal entries of x is 18 and x minus 30 times identity is invertible. Okay, so if you read that, you should think about what is given. Yeah, so we are talking about matrices and like a product here and some transposing stuff. And if you take a look at the matrices pi, they should look very familiar. These matrices are called permutation matrices. Okay, they are orthogonal. This is very important here, and these are the keywords how to solve it. Then we should think about what can us help. Of course, we should be familiar with some basic matrix operations, especially transposing and so on. And if we think about the answers 1 to 4, we can get an idea what's going on. X is symmetric. Yeah, this is possibly true. It makes sense because the middle matrix is symmetric. And yeah, so 1 is true or not. And we will solve it how? We will solve it directly. We showed this property directly. Question 2 is about eigenvalues and eigenvectors. So one can think about the characteristic polynomial of x, but you will see soon that this way is not an optimal for us, because we do not know something about the sum of characteristic polynomials. Okay, and so you should think about this 1, 1, 1 vector. Yeah, it's not given because 1, 1, 1 looks nice. It's given because of one certain purpose. Yeah, and every detail you should think of why is this the case, and we will see. Yeah, the sum of diagonal entries, yeah, it is also possible. Why not? We will try to calculate it directly, and we should know about some rules for the sum of diagonals. Okay, and also very important, question 4. If the second question is true, then immediately 4 is false. Okay, because if 30 is an eigenvalue, we know that the determinant of this matrix is 0, and determinant 0 is not invertible. Okay, so if 2 is true, then 4 is false, and vice versa. Okay, good. X is symmetric. How can we do it? Okay, we show it directly. We start with x transposed, then we manipulate our expression, and if we get to x, question 1 is true. If we do not get x, question 1 is false. Okay, and here, do not work stupid. What I mean by that is we will not evaluate x precisely, so we do not evaluate all 6 products, and the same for the transposed, and then we compare it. This is of course possible, but it takes much time, and it's not the goal of the exam. Okay, so we have to think smart. And how do we do that? So we will see. So the first step is, you should know that transposing is linear, and if we transpose a product, the factors switching the positions. Okay, so we start with x transposed. This is by definition of x. We transpose the whole sum. Because transposing is linear, we can move the summation outside. Okay, then how do we transpose a product? We switch the order of the multiplication, and we transpose each factor. Then it looks like this. Then we know about transposing that it's self-inverse. This means P transpose is P. Or matrix M, if we transpose it, we get M, because M is symmetric. We can just take a look to M, and we see M is symmetric. Okay, and now our final sum is exactly x. So so question 1 is true. X is symmetric, and we prove that via direct calculation, just by using the properties of transposing. Okay, this is very easy if you know about transposing. Okay. Question 2. Yeah, like I said, of course we could try to evaluate the determinant of x minus mu times identity matrix. Then we get the eigenvalues mu, and then we can maybe get eigenvector 1, 1, 1. This is also possible, but very time spending, and it's not the goal of the exam. Okay, so we should care about the 1, 1, 1. Why 1, 1, 1? What is so special about that? And it's easy to see if you calculate P times V, you get V itself. Yeah, so for a permutation matrix, the vector V 1, 1, 1 is an eigenvector for this permutation matrix. That's why. And so what we see P times V is V itself. Then the product M times V is not depending on K, so we put it outside the summation. And the sum of this permutation matrices, it's easy to see to get 2, 2, 2, 2, 2, 2, so all entries are 2. Yeah, and matrix multiplication is associative, so we can take care of about the matrix with a bunch of 2's times the matrix M. This is easy to calculate. You get in each row 12, 6, 12. And finally, we calculate the product with vector 1, 1, 1 to get 30, 30, 30. And 30, 30, 30 is 30 times 1, 1, 1. So question 2 is true. And all we need is the knowledge that these permutation matrices with vector 1, 1, 1 is 1, 1, 1. Okay, this is the main step in my opinion. The rest of this calculation is straightforward and very easy. Okay, so here it's important that you see that these permutation, these PIs, these are permutation matrices. This is very easy to observe. It's very important to observe. Okay. Question 3. Diagonal. Sum of diagonals is 18. Yes. What we need here is we need some basic properties of the trace, and the first one is so the sum of diagonals, it's called the trace, and the trace is linear. This is trivial. This is given by, it follows by definition of addition from matrices. Okay, and the second one is that the trace of a matrix A is the same if we put a p to the left and a p minus to the power minus 1 to the right to A. Okay, this is the key property. This is what you should know. And our problem is we have not P inverse, we have P transposed. But because these matrices P are orthogonal, what do we know? We know from orthogonal matrices that P transposed is P inverse. Okay, so first step is the trace is linear, so we put the summation outside. Then P transposed is P inverse because P is orthogonal. Then we know by property 2 that the trace is conversed. So we get trace of X is the sum K from 1 to 6 from trace M. M is not depending on K, so we get 6 times trace M, and M, the trace of M is very easy. It's 3. 6 times 3 is 18. So question 3 is true. And like I said, question 4 is false. Why? Because 2 was true. 30 is eigenvalue by question 2. Therefore, x minus 30 times in identity is invertible. It's false. Alright? Good. That was the first question. Now we take a second question from sheet 2, question 1. We take a look. It looks very horrible for real A's and absolute value of A greater 1. Let this limit blah 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 equals 54, then the possible values of A is R, and then a bunch of options. Okay. Yeah, how can we do this? We read carefully and we see it's about a limit from two summations, and the summation, they have some structure. Okay. And yeah, of course you can get the idea to try some geometric series, to try some telescoping series, and so on. And we have a mysterious n to the power 7/3 in the denominator here. Okay, this is also for a special purpose. It's not there to make you afraid of something. It's there because we will get a nice result. Okay, so in the first step we ignore this n to the power 7/3, but we will see this, it's there on purpose. And whenever you see such a sum and the geometric series is not helping, telescoping is not helping, think about Riemann summation. This is a good try, and we will do this, and we will see the question is very easy if we try the Riemann summation. And also what we are looking for, values of A. So at the end we should get maybe a linear equation in A, maybe quadratic equation in A, maybe cubic equation in A. So we will see if we get one value or maybe two values or maybe more. Okay. So like I said, it's a good idea to try the Riemann summation. How do I come up with this? If you are experienced in such summations, it's a quite natural approach to try the Riemann summation. Okay, we make a small recall. So first we write numerator and denominator with the summation sign. It's more compact. Okay, so please make sure by yourself that this here is correct. And I make a small recall, and the limit of 1 over n from some summation from k1 to n of some function evaluated at k over n as n goes to infinity. This is exactly the definition of integral from 0 to 1. This is called upper sum. Okay, and of course we do not care about convergency and stuff like that. All the functions, square root and something like that, it should be convergent, so we can get rid of that. Okay, and if you know this nice formula for the upper sum, then you know what you have to do to come to this form. Okay, so we take a look at the numerator and to the denominator, and we will see what's going on here. Okay, so first what I want to do is in the numerator I extend the k via n over n. Okay, this is what I can do, and the same I do with the denominator. I extend via n over n. Okay, why I do this? Because I want here something over n. Okay, so all what we have to do is we have to get rid of the n in the numerator. Okay, because roots are multiplicative, we can put a cube root of n outside the summation. Okay, n is not depending on k, and cube root is multiplicative, so we can get cube root of n outside. All right. In the denominator, from the denominator, we factor 1n outside. All right. And yeah, the next step is, what can be the next step? We put here this n squared, we put so product squared is the squares of the products. Okay, so n squared we get outside, and here an plus k over n is a plus k over n, and also here we have our k over n. This is very beautiful. Yeah. Okay, and the next step is, you can make sure by yourself that all these n's, cube root n, n squared, and n to the power 7/3, this cancels out, so we are left with summation over summation. And for our Riemann sum, we extend our ratio by 1 over n. Okay, and now we have our nice Riemann summation, and all we have to do is, we can write it, where is it? 1 second. Here, yeah, we extend with 1 over n times 1 over n. And yeah, we know the summations are convergent and stuff like that, so the limit of our quotient is the quotient of the limits. Okay, this is a limit rule. Now we have a numerator and denominator exactly the upper sum from an integral, so we can move to integral 0 to 1 of x over a to the power 1/3, and integral from 0 to 1 from 1 over a plus x squared equals 45. And yeah, this is, from there it's easy to find the values from a. The numerator is 3/4, and the denominator, if you integrate, you get 1 over a minus 1 over a plus 1. And from there it's very easy to find a squared plus a minus 72 is 0, and therefore a is 8 and 9. Perfect. And we see 8 and 9, 8 and minus 9, so 1 and 2 is true. Okay, and that's all for today. I just want to mention one more thing again. Of course, this summation looks really crazy, okay, and if you know a lot about structured summations like here, yeah, you have a very beautiful structure, and geometric series is maybe not working. Also, you have a limit, also as n goes to infinity. It's a nice try to write it in an integral form. Okay, and from there it's very easy. So that's it for today. 2 questions from the JEE advanced exam. Yeah, in a couple of days, I guess, the rest of the sheet 2019 will follow. You can try the other questions by yourself. Yeah, I hope you liked the video. Bye bye, see you next time.